Imagine a wooden ship that has weathered many voyages. Over the years, its planks rot and its sails fray, so the crew replaces each part piece by piece. Eventually, every single plank, mast, and nail has been swapped out for new ones. The ship still looks the same and sails just as before. But a question lurks: is it still the same ship? This classic thought experiment, known as the Ship of Theseus, asks what truly defines the identity of an object. Is it the material it's made from, or the continuous history it carries? As the ship is repaired over time, there's never a clear point when it stops being itself. If it isn't the same ship, then when exactly did it change? After the first plank was replaced? The 10th? Or only once none of the original pieces remained? Now, take it a step further. Imagine someone gathers all those old, discarded planks and nails and rebuilds the original ship exactly as it was. Now there are two ships, one that underwent gradual change and one rebuilt from the original parts. Which one is the real Ship of Theseus? Or could both somehow be the original in different ways? This puzzle doesn't have a simple answer. It forces us to consider what sameness really means. It's not just about an old ship, it's a metaphor for us. Your body's cells are replaced over your lifetime, yet you feel like the same person. So what makes you you? Is it your physical parts, your memories and personality, or something less tangible? The Ship of Theseus reveals that identity isn't fixed like a statue, it's fluid and ever-changing. Perhaps what we call our identity is just a continuous story we tell ourselves, holding together all the changes over time. Imagine you could travel back in time. You step into a time machine and set the dial for decades before you were born. You arrive in your grandfather's youth and, by accident or intention, you prevent him from ever meeting your grandmother. In that moment, history changes. Your father or mother is never born, and as a result, you are never born. But here's the catch. If you were never born, how could you have traveled back in time to begin with? This mind-bending scenario is known as the Grandfather Paradox. It's a classic thought experiment in time travel that breaks our normal ideas of cause and effect. Your trip to the past, the cause, wipes out your own existence, the effect, which logically means you couldn't have made the trip at all. It's a loop of contradictions, like a snake eating its tail. The paradox highlights a simple question with no simple answer. Can the past be changed without breaking reality as we know it? Think about what this implies. Maybe it means time travel to the past is impossible. Perhaps the laws of the universe simply won't allow such contradictions. Or, if it is possible, perhaps something in time would correct the paradox, ensuring events still lead to you being born. Fate finds a way. Another intriguing idea is the multiverse. Changing the past might create a whole new timeline. In that case, you never erase your existence. You just find yourself in an alternate reality where you were never born, while the original timeline remains intact. The Grandfather Paradox doesn't come with a tidy solution. Instead, it forces us to wonder how time really works. Is the past fixed, or can it be rewritten? If we ever did invent a time machine, would the universe have safeguards to prevent paradoxes? Ultimately, this thought experiment reminds us that time and causality might be far more complex and stranger than they appear. It's a humbling reminder that some puzzles in the universe might never have a definitive answer. Imagine you come across a diary filled with brilliant ideas and inventions, and it has your name on it as the author. The strange part is, you don't recall ever writing it. In fact, you haven't written it yet. Curious and inspired, you eventually use the diary's knowledge to create those inventions and end up writing the very same diary in the future. Here's the mystery. Where did the information in that diary originally come from? This scenario is known as the Bootstrap Paradox. a time travel puzzle where an object or piece of information loops in time without a clear origin. In our case, the diary exists because you brought it back from the future, and you only wrote it because the diary already told you how. Cause and effect get tangled in a circle. The name bootstrap comes from the old phrase, pull yourself up by your bootstraps, meaning to do something impossible. Fittingly, this paradox is about achieving the impossible, creating something from nothing. To see it another way, imagine a scientist from the future travels back to meet her younger self. She hands over the blueprints for a time machine. The young scientist builds the machine and eventually grows up to travel back in time and hand over those same blueprints. The machine's plans have no true beginning. They exist in an endless loop, violating the normal rule that every effect must have a cause. Here, the cause is the effect, and the effect is the cause. The Bootstrap Paradox raises big questions about free will and reality. If information or objects can loop like this, does anyone ever truly invent or discover them, or were they always just there? It challenges our assumption that time flows in one direction with a clear chain of events. Science fiction loves to explore this idea. Think of movies like Terminator, where future and past events feed into each other. In the end, the Bootstrap Paradox leaves us pondering a universe where some things have no origin at all. It shows how our linear understanding of time might be only part of the story. Like other great paradoxes, it doesn't offer a neat solution. Instead, it invites us to marvel at how strange causality and time can be, and how reality might be woven in loops beyond our comprehension. Imagine a sealed box containing a cat, a vial of poison, and a tiny radioactive element. Inside this closed box, a strange and mind-bending scenario unfolds. According to the laws of quantum mechanics, as long as we don't peek inside, the cat can be thought of as both alive and dead at the same time. How could a cat be alive and dead simultaneously? This is the famous thought experiment known as Schrödinger's cat, proposed in 1935 by Austrian physicist Erwin Schrödinger to illustrate the bizarre nature of quantum reality. Here's how it works. The radioactive element might randomly decay or it might not. If it decays, it triggers the vial of poison to break, which would kill the cat. If it doesn't decay, the poison stays sealed and the cat lives. The twist is that in the quantum world, tiny particles like atoms can exist in multiple states at once, a concept called superposition. Until we observe what happened, the radioactive atom is in a superposition of decayed and not decayed. That means the cat's fate is also in a superposition. It is both dead and alive in this theoretical scenario, a paradox that defies common sense. Schrödinger intended this scenario as a critique of the more extreme interpretations of quantum physics. It highlights how quantum rules, which make sense for subatomic particles, lead to absurd conclusions if applied to everyday objects. The moment someone opens the box to check, the spell is broken. The cat ends up definitely alive or definitely dead, not both. The act of observation collapses the multiple possibilities into one reality. This raises profound questions. Does something only become real when it is observed? What counts as an observer? A human, a camera, or even the Geiger counter inside the box? Schrödinger's cat forces us to confront how mysterious and counterintuitive the quantum world is. It reminds us that at the tiniest levels of existence, the rules can be very different from what we're used to, challenging our understanding of reality itself. Can an all-powerful being create a rock so heavy that even they cannot lift it? This simple but confounding question lies at the heart of the Omnipotence Paradox. It asks us to examine what it really means to be all-powerful, omnipotent. No matter how you try to answer, it seems to tie itself in a logical knot. If the being can create a stone too heavy to lift, then there is something it cannot do, lift that stone, meaning it wouldn't be truly all-powerful. But if it cannot create such a stone, then there is also something it cannot do, make the unliftable stone. Either way, the idea of unlimited power runs into a contradiction. Philosophers and theologians have wrestled with this puzzle for centuries. Some have suggested that true omnipotence doesn't include doing the logically impossible. In other words, tasks like creating a square circle or making a rock so heavy it can't be lifted are nonsense tasks. They break the rules of logic and thus don't count as real actions at all. By this view, an all-powerful being can do anything that is meaningfully possible, but not things that are self-contradictory. Others have taken a different stance, proposing that an omnipotent being might be able to do absolutely anything, even if it defies logic as we understand it. However, that idea is deeply unsettling because it means logic and reason would no longer apply. The Omnipotence Paradox isn't just a theological trick question, it has a broader message. It challenges us to think about the limits of language and concepts. Can the notion of unlimited power even make sense in a logical framework? This paradox reveals that some questions we can pose are inherently problematic. It shows that even the concept of absolute, no-limits power might be self-defeating when we examine it closely. In the end, the Omnipotence Paradox reminds us that certain ideas, like infinite power, may be more complicated or even impossible than they first appear, inviting humility about what can or cannot exist. Imagine a small town with a single barber who abides by a very strange rule. He shaves all and only those men in town who do not shave themselves. At first, this rule sounds straightforward. The barber's job is to take care of anyone who doesn't shave his own beard, and he never touches those who do shave themselves. But this setup hides a mind-twisting question. Who shaves the barber? Let's think it through. There are two possibilities for the barber. Either he shaves himself or he doesn't. If the barber shaves himself, he would violate the rule, because the rule says he only shaves people who do not shave themselves. But in this case, he is shaving someone, himself, who does shave himself, a contradiction. On the other hand, if the barber does not shave himself, then according to the rule, he falls into the category of people in town who don't shave themselves. And who is supposed to shave those people? The barber. That means he is required to shave himself. If he doesn't shave himself, another contradiction. No matter what, the poor barber can't follow his own rule without breaking it. This puzzle is the Barber Paradox, a classic example of a self-referential problem. It was popularized by the mathematician and philosopher Bertrand Russell as a way to illustrate a deep issue in logic and set theory. In essence, it's a more relatable version of Russell's paradox, which asks if there is a set of all sets that do not contain themselves. The Barber story shows in everyday terms how a definition can undermine itself. The deeper lesson is that not all rules or questions make sense when they refer to themselves. The Barber Paradox reminds us that language and logic have limits. Even a simple-sounding rule can collapse into nonsense if we're not careful. It's a playful but profound warning about hidden contradictions in our reasoning. Travel back to ancient Greece and imagine a foot race between the swift warrior Achilles and a slow-moving tortoise. Achilles is so fast that he generously gives the tortoise a head start. Now, common sense says Achilles will easily overtake the tortoise. But the philosopher Zeno of Elea posed a clever argument suggesting that Achilles could never catch up to the tortoise. How could that be? Zeno's reasoning creates one of his famous paradoxes of motion, which have puzzled thinkers for centuries. Here's Zeno's argument in the Achilles and the Tortoise Paradox. First, Achilles runs to the tortoise's starting point. By the time he gets there, the tortoise has moved a little forward. Next, Achilles runs to where the tortoise now is, but in that time the tortoise has inched ahead again. Achilles keeps closing the gap, but every time he arrives at the spot the tortoise was, the tortoise has moved to a new spot further on. Achilles is always running to where the tortoise was, and the tortoise is always a tiny distance ahead. In theory, this could go on forever. There will always be some distance, however small, left for Achilles to cover. If you follow this logic, it seems Achilles can never actually overtake the tortoise, because there are infinitely many little distances he must run. Yet in reality, of course, Achilles would pass the tortoise quickly. So where is the flaw? Zeno crafted this paradox, along with others, like the paradox of an arrow that appears motionless at each instant, to challenge our understanding of infinity, space, and time. The Achilles paradox highlights how dividing a task into infinitely many tiny steps can make a finite action seem impossible. The resolution came much later with the development of mathematics, specifically calculus and the concept of limits. We now understand that those infinitely many tiny distances Achilles runs can sum up to a finite distance, allowing him to overtake the tortoise after a finite time. But in Zeno's era, without the math to resolve it, the paradox was deeply mystifying. Zeno's paradoxes remind us that our intuitions about motion and infinity can be misleading. They pushed the development of math and philosophy, showing that even everyday things like moving from point A to B can hide profound complexities when you examine them closely. What if the harder you chase happiness, the more elusive it becomes? This is the paradox of hedonism, the idea that directly pursuing pleasure and happiness may actually prevent you from ever attaining them. On the surface, it makes sense to seek out the things that make us happy. Hedonism is the philosophical belief that pleasure or happiness is the highest good and should be the main goal of life. If feeling good is the point of living, why not go after it with everything you've got? Yet, many people find that when they focus solely on trying to be happy, happiness slips through their fingers. Consider someone who wakes up each day determined to feel nothing but joy. They avoid anything unpleasant and seek constant fun and gratification. Paradoxically, this person might end up less happy over time. Because when you fixate on happiness as a goal, you start constantly evaluating your state. Am I happy yet? Is this as fun as it should be? This self-awareness can undermine the joy of the moment. Small disappointments or the normal ups and downs of life become magnified when you're desperately trying to maximize pleasure at every second. It's a bit like trying too hard to fall asleep. The more you think about it, the harder it gets to actually fall asleep. On the other hand, think about times you felt truly happy without trying, getting lost in a hobby, helping a friend, or achieving something meaningful. In those cases, you weren't chasing happiness directly. It came as a natural byproduct. Psychologists and philosophers note that people who focus on meaningful activities, relationships, personal growth, or helping others often end up happier than those who pursue pleasure alone. The paradox of hedonism teaches a valuable lesson. Happiness is usually a side effect of other things we do, not something obtained by relentless grasping. By living a balanced life and engaging in activities we find meaningful, we often find that joy sneaks up on us when we least expect it. In short, sometimes the best way to be happy is to stop worrying so much about being happy and instead immerse yourself in life, letting happiness find you in its own time. This sentence is false. At first glance, that line looks like an ordinary statement, but try to figure out whether it's telling the truth or lying and you'll find yourself in a tangle. This is the classic liar paradox, a self-referential puzzle that has been known since ancient times. The crux of it is simple. If the sentence, "This sentence is false," is telling the truth, then what it says must be the case, meaning the sentence is false. But if it's false, then what it says isn't true, which would mean the sentence is actually true. Either way, we hit a contradiction. It's a logical loop with no comfortable way out. The liar paradox highlights a fundamental problem in logic and language. Certain self-referential statements just don't fit into our usual true/false framework. The paradox has a long history, with versions appearing in Greek philosophy, like the story of a Cretan man who says, "All Cretans are liars." It's not just a party trick or a word game. This simple paradox has serious implications. When logicians and mathematicians tried to formalize the rules of truth and proof, the liar paradox served as a cautionary example of how language can undermine itself. In fact, the famous mathematician Kurt Gödel used a similar kind of self-referential statement to prove his groundbreaking incompleteness theorems, showing that even rigorous logical systems have limitations. How do we deal with the liar paradox? There isn't a universally agreed-upon solution. Some have proposed that the statement is neither true nor false, essentially breaking the normal rules of logic to create a third category. Others suggest it's meaningless or that our language needs a hierarchy, so a sentence can't directly talk about its own truth without causing trouble. But perhaps the most important takeaway is what it reveals about our thinking. Even in something as basic as a single sentence, there can lurk a contradiction that defies resolution. The liar paradox reminds us to be humble about truth and logic. It shows that not every question has a clear answer. Some can loop back on themselves forever, challenging our assumptions about what truth even means. When does a heap of sand stop being a heap? The Sorites Paradox, from the Greek word soros meaning heap, poses this simple yet confounding question. Imagine you have a large pile of sand, clearly a heap. Now, remove one grain of sand. Intuitively, it's still a heap. Taking away just one grain won't change that. Remove another grain, and another. Surely it's still a heap, just 2 grains lighter. If you keep going, removing grain after grain, something puzzling happens. You can remove grains one at a time, and each time it's hard to say that that single grain made the difference between heap and non-heap. But if you carry on long enough, you'll eventually have just a few grains, and then only one grain, and finally none at all. At some point along the way, the heap vanished. Yet there was never a clear moment when you could point and say, now it stopped being a heap. This is the Sorites Paradox, also known as the heap paradox. It highlights the problem of vague definitions. Terms like heap, tall, rich, or bald don't have precise boundaries. One person might still call a certain collection of sand a heap, while another might not, and there's no obvious fact of the matter to settle it. The paradox can be illustrated with other examples. If a man is not bald, removing one hair won't suddenly make him bald. Remove hairs one by one, and there's no single hair whose loss is the magic moment of becoming bald. Yet eventually the man will be bald. The Sorites Paradox shows a clash between the way logic works and the way our language works. Classical logic likes clear, yes or no categories, but many real-world concepts are fuzzy. If we insist that each tiny removal doesn't change the status, we end up with a contradiction, like concluding that even 0 grains could still be a heap, which is absurd. Philosophers have proposed various solutions, like accepting blurry boundaries or using degrees of truth instead of a simple true/false. The key takeaway is that not everything in life has a sharp line separating one state from another. The Sorites Paradox reminds us of the ambiguity in many of our everyday concepts and cautions that our quest for neat definitions can run up against the inherently fuzzy nature of the world. A prisoner is condemned to be executed, and the judge tells him, the hanging will occur at noon on one weekday, Monday through Friday, in the coming week, but it will be a surprise. You won't know which day it is until the morning of the execution. The prisoner returns to his cell and starts thinking through this promise, trying to guess the day. He reasons that it can't happen on Friday. Because if he's still alive by Thursday night, then only Friday remains, and the execution wouldn't be a surprise anymore. He'd know it must be Friday. So he confidently rules out Friday. Now he considers Thursday. If the execution hasn't happened by Wednesday night, and he's already ruled out Friday, then it must happen on Thursday, but that would make it predictable, not a surprise. So it can't be Thursday either. By the same logic, he eliminates Wednesday, then Tuesday, then Monday. In the prisoner's mind, there's no day left that fits the judge's criteria. He concludes that the surprise hanging won't happen at all. Feeling relieved, the prisoner goes about his week expecting a reprieve. Then, on Wednesday at noon, the executioner shows up, and the prisoner is hanged, much to his shock. It was indeed a surprise. Everything the judge said came true, yet the prisoner's careful reasoning seemed perfectly logical. This is the unexpected hanging paradox, also known as the surprise exam paradox, when told with a surprise test instead of an execution. It's a brain teaser about reasoning and expectations. The prisoner's mistake lies in the very act of trying to outsmart the announcement. By assuming he could predict the surprise, he trapped himself in circular logic. When he ruled out Friday, he was implicitly assuming he'd survive through Thursday, an assumption that turned out false when the hanging occurred earlier. The unexpected hanging paradox highlights a curious aspect of knowledge. Predicting what you will or won't know can be paradoxical in itself. It shows how a perfectly sensible line of reasoning can fail when it involves self-referential conditions, in this case, the condition of being surprised. Philosophers and logicians have debated the finer points of why the prisoner's argument fails, but there's no universally agreed solution that feels completely satisfying. In a way, that's the charm of this paradox. It demonstrates that even our reasoning about simple future events can tie itself in knots. It reminds us that sometimes you can overthink things, and life still has a way of surprising you. If someone told you that looking at a green apple could help prove the statement, "All ravens are black," you'd probably think they were joking. What could an apple possibly tell us about ravens? Yet logically, there's a twist here. This is the paradox of the ravens. It highlights a counterintuitive quirk in how we think about evidence and confirmation. Here's the idea. The statement, "All ravens are black," is logically equivalent to saying, if something is not black, then it is not a raven. Now, how do we normally try to confirm all ravens are black? We'd look at ravens to see what color they are. But consider the contrapositive form. If we encounter something that is not black, like a green apple, and it's also not a raven, this doesn't conflict with the rule at all. It actually fits the statement, if not black, then not a raven. In a strict logical sense, observing a green apple provides a tiny bit of support for the idea that all ravens are black, since it's yet another case that doesn't break the rule. This sounds absurd because intuitively, seeing a green apple doesn't tell us anything new about ravens. We feel that only looking at ravens should matter for a claim about raven color. The paradox exposes a gap between formal logic and our intuition about evidence. Logically, any observation that doesn't disprove all ravens are black is somewhat confirming it, but in practice we only consider relevant observations, like examining ravens themselves, as meaningful evidence. Not all confirming evidence is equal. Seeing countless non-black objects that aren't ravens doesn't actually increase our confidence that ravens are black, whereas finding even one non-black raven would immediately disprove it. Ultimately, the paradox of the ravens reminds us that context and relevance are crucial when thinking about evidence. Pure logic might label a green apple as evidence that all ravens are black, but our common sense says otherwise. This puzzle reveals that confirming a general rule is not just about accumulating instances that don't contradict it, It's about finding the right kind of evidence that genuinely tests the rule. In this way, a seemingly silly scenario about ravens and apples leads us to deeper questions about how we gain knowledge and what it means to prove something. Imagine a famed teacher of law in ancient Greece who takes on a bright student. They strike a deal for the tuition. The student will pay the teacher's fee only after he wins his first court case. After completing his training, the student decides not to practice law and never goes to court, effectively avoiding any situation where he might have to pay his teacher. Frustrated, the teacher finally sues the student to get his payment, and the result is a perplexing legal puzzle when the case is heard. In court, the teacher presents his argument. No matter what happens in this trial, I should be paid. If I win this case, the court will order you to pay me my fee. If you win this case, that means you will have won your first case, which was our agreed condition for payment, so you must pay me then as well. Either way, I get paid. The teacher feels triumphant with this logic. But the student replies with an equally crafty argument. If I win, the court's decision means I owe you nothing. If I lose, then I still haven't won a case yet, which means the contract's condition isn't met, so I don't have to pay you either. Either way, you get nothing. Both arguments sound convincing. If the court sides with the teacher, the student's reasoning would undo that victory, but if they side with the student, the teacher's reasoning collapses. This is the paradox of the court, sometimes called Protagoras' paradox, after the supposed teacher in the story. No matter what, the verdict itself triggers a contradiction about whether the fee should be paid. According to legend, the judges, baffled by this, postpone the case indefinitely rather than resolve it. The paradox of the court highlights how a clever agreement can backfire when its conditions entangle with the outcome of a dispute. It's a self-referential loop in a legal setting. The very act of deciding the case affects the condition on which the decision is based. In broader terms, it shows that sometimes our contracts, promises, or logical rules can create no-win situations where two perfectly logical interpretations directly conflict. It's a reminder that real life can produce no-win scenarios where our rules end up contradicting themselves. This ancient puzzle remains a classic example of a legal conundrum that has intrigued thinkers for centuries. Imagine someone tells you that spotting a green apple could provide evidence that all ravens are black. At first, this sounds completely absurd. What could apples possibly have to do with ravens? This strange scenario introduces the paradox of the ravens, first proposed by philosopher Carl Hempel in the 1940s to illustrate an unexpected quirk of logical reasoning. Here's how it works. The statement, "all ravens are black," logically means the same as saying all non-black things are not ravens. Therefore, every non-black non-raven we encounter, like a green apple, technically supports this statement. After all, it doesn't contradict it. But this logic feels oddly counterintuitive. Observing black ravens seems genuinely relevant evidence, while observing apples feels irrelevant, even meaningless. Yet, according to formal logic, both equally confirm the hypothesis. This paradox challenges our intuition about evidence and confirmation. Our brains naturally give weight to relevant, direct evidence. Seeing a black raven matters far more than seeing something unrelated. But logically, even the unrelated observations count, no matter how trivial they seem. Philosophers call this a puzzle of confirmation theory, revealing how tricky it can be to clearly define what counts as evidence. The paradox of the ravens gently nudges us to reconsider how we understand and process information. Does logic always align with intuition? Or does our intuitive reasoning sometimes blind us to truths hiding in plain sight? This paradox quietly whispers that perhaps the way we think about evidence and confirmation is far stranger and far less straightforward than we believe. In ancient Greece, a promising law student struck a peculiar deal with his renowned teacher. The agreement was simple yet puzzling. The student would only pay for his education once he won his first legal case. After years of rigorous training, the student chose not to practice law, believing this decision would free him from pain. Frustrated, the teacher sued his student, confident the court would side with him. The teacher reasoned clearly, "If the court decides in my favor, the student must pay as ordered." But even if the student wins, he would have won his first case, thus triggering our agreement. He would still owe payment. However, the student cleverly argued back, "If I lose, according to our agreement, I've still never won a case and thus owe nothing. But if I win, the court itself confirms that I owe nothing. Either way, I pay nothing." Both arguments appear flawless, yet both cannot be correct simultaneously. This dilemma illustrates the paradox of the court, a captivating puzzle revealing how logical agreements can sometimes contradict themselves. The paradox exposes subtle cracks in our assumptions about language, law, and logic. It also raises fascinating questions about fairness and consistency in rules and agreements. In everyday life, we assume legal agreements clearly protect fairness. Yet here, perfect logic spins into confusion. The paradox of the court reminds us that even simple agreements, when framed self-referentially, can spiral into contradictions, softly challenging the certainty with which we trust our reasoning. Are your actions truly yours, or are you merely following a predetermined script dictated by past events? This unsettling question lies at the heart of the paradox of free will. It challenges us to confront whether genuine freedom exists or if everything we do is an inevitable outcome of a chain of causes stretching back to the dawn of the universe. Think about your choices today. Perhaps you chose what to eat, what clothes to wear, or even what to think about. But behind every decision, there is a chain of previous causes: genetics, upbringing, environment, and countless microscopic events shaping your life. If every action is predetermined by these factors, where is there room for free will? If you're simply a product of cause and effect, then your sense of choice may just be an illusion. Yet, this conclusion feels deeply uncomfortable. Intuitively, we all feel like authors of our own stories, capable of making meaningful decisions. It's difficult, even disturbing, to accept that every thought, decision, and action could already be pre-written by an intricate web of prior conditions. Philosophers have long debated this paradox. Some argue determinism must be true, leaving no room for freedom. Others suggest that consciousness itself might transcend pure cause and effect, creating room for genuine choices. A few propose a middle ground, that free will and determinism might somehow coexist in ways we do not yet fully understand. The paradox of free will doesn't offer easy answers. Instead, it encourages quiet contemplation about who we truly are and how we fit into the universe. It gently reminds us that perhaps, beneath the surface of our lives, there's a profound mystery we may never fully grasp. Should a tolerant society tolerate intolerance? This seemingly straightforward question reveals a deeper, hidden tension within the very idea of tolerance itself. Philosopher Karl Popper famously articulated this paradox, noting that if a society is infinitely tolerant, even toward those who are intolerant, it eventually risks being overtaken by intolerance. Imagine a community that welcomes all viewpoints equally, including extreme beliefs advocating intolerance. Over time, these intolerant views could grow, eventually suppressing and eliminating the very tolerance that allowed them to thrive in the first place. Infinite openness ironically leads to its own destruction. Thus, true unlimited tolerance is ultimately unsustainable. On the other hand, Restricting certain beliefs or speech in the name of protecting tolerance contradicts the fundamental principle of being open and inclusive. This dilemma forces us into an uncomfortable corner, questioning how a tolerant society must sometimes set limits on tolerance itself to survive. It's an ethical tightrope. How much intolerance can a society accept before it must intervene to protect its own ideals? The paradox of tolerance is not just philosophical theory. It profoundly shapes contemporary debates about free speech, democracy, and civil liberties. It gently reminds us that absolute tolerance might be an admirable ideal, but practically impossible to achieve without inviting its own destruction. It subtly encourages reflection on the delicate balance between openness and protection in the societies we build. Picture an author who has carefully written a book filled with facts, research, and well-supported claims. Confident in their meticulous efforts, they believe wholeheartedly that each statement in the book is true. Yet, in the preface, they candidly acknowledge something intriguing. I am certain there must be some errors in this book. This is the paradox of the preface, a fascinating contradiction in belief. The author rationally accepts that human error is inevitable. Even the most diligent researcher can't achieve absolute perfection. So, the author simultaneously believes every sentence is correct and that at least one sentence must be wrong. How can both these beliefs coexist logically? This paradox forces us to question the nature of rational belief and human fallibility. It demonstrates a subtle tension between being confidently thorough and acknowledging the imperfection inherent in any human endeavor. The paradox suggests that true rationality includes recognizing the possibility, indeed, the inevitability, of error, even while believing strongly in one's accuracy. It also illustrates the complexity of knowledge itself. We often assume that rational belief requires certainty, yet this paradox reveals that absolute certainty may actually be irrational. Rational belief might instead mean holding our truths lightly, accepting a quiet uncertainty. In other words, being rational doesn't mean being infallible. It means carefully balancing confidence with humility. The paradox of the preface gently teaches us to embrace humility even when we feel confident. It reminds us that acknowledging our limits and imperfections may, paradoxically, be one of the wisest actions of all. Imagine searching for something you do not yet know. If you already know what you're looking for, there's no need to search. But if you don't know it, how will you recognize it when you find it? This puzzling scenario is known as Meno's paradox, famously presented by the ancient Greek philosopher Plato through his dialogues with a student named Meno. It challenges the very nature of learning, knowledge, and discovery itself. Think about learning something entirely new, something you've never encountered before. How can you ever recognize it as the right answer if it's completely unknown to you? The paradox implies that genuine discovery might be impossible, since you'd either already know the answer, making the search unnecessary, or never recognize the truth even if you stumbled upon it. This creates a disturbing dilemma. If all learning requires prior knowledge, how is new knowledge ever gained? Plato suggested a remarkable solution. Maybe we never truly learn new things, but instead we simply remember knowledge that our souls already possess. In other words, knowledge is innate, residing within us, waiting to be rediscovered. Modern interpretations of the paradox propose less mystical explanations, suggesting we learn by recognizing patterns or using analogies and partial understandings that guide us toward fuller truths. Meno's paradox pushes us to reconsider the very process of learning and discovery. It gently reminds us that gaining knowledge isn't merely finding facts, it's about navigating the unknown with curiosity, intuition, and a willingness to recognize when we've found what we're seeking, even when we didn't clearly know it at the start. Imagine you want to deeply understand the true meaning of a concept, like justice, freedom, or happiness. To achieve this understanding, you perform an analysis, carefully dissecting the idea into smaller, clearer parts. Ideally, this analysis would explain the concept completely, giving you insight you didn't have before. But here's the paradox. If your analysis is entirely correct, it should offer no new insight at all, because it would merely restate something you already knew. If the analysis does offer genuinely new information, however, it must be saying something slightly different than the original concept, thus not truly analyzing the original idea at all. This is known as the paradox of analysis. It arises because good analyses should clarify the meaning of something without changing it. Yet, paradoxically, any successful clarification would seem to introduce something new, meaning it's no longer analyzing the original concept purely. Philosopher G. more famously wrestled with this paradox, noting that every attempt to clarify concepts seems trapped between redundancy and distortion. Take a simple example: a brother is a male sibling. If this analysis is accurate, it simply restates what we already knew, providing no fresh insight. But if it tells us something genuinely new about the concept of brother, perhaps adding details or context, then it risks no longer describing what a brother truly is. Either way, there's an inherent tension. This paradox subtly points out that some things may resist simple, straightforward analysis. It highlights that human language and concepts often possess nuances and layers of meaning that evade neat definitions. We might need to accept that certain ideas can never be perfectly captured in words alone, always slightly eluding perfect clarity, always slightly beyond precise definition. The paradox of analysis quietly teaches us humility about our attempts to fully grasp the meanings behind our most cherished ideas, gently suggesting that sometimes perfect clarity may be forever just beyond our reach. Consider a lottery with 1 million tickets, exactly one of which is guaranteed to win. If someone asked you, "Will ticket number 1 win?" you'd reasonably reply, "Probably not." With only a 1 in a million chance, rationally, you can safely assume it won't win. And if someone asked the same question for ticket number 2, number 3, or any ticket, your answer would logically remain, "Probably not." You could confidently say this about every single ticket individually, yet, paradoxically, you also know one ticket must certainly win. This is the lottery paradox, an intriguing puzzle that exposes the conflict between probability and certainty. Logically speaking, each ticket individually has an almost certain chance of losing. Yet collectively, you know with absolute certainty that one of these, almost certainly losing, tickets will indeed win. So, what exactly should you rationally believe? Should you trust the statistical improbability of each ticket winning individually, or the absolute certainty that one ticket must win? This paradox isn't just theoretical. It reveals subtle complexities in how we handle knowledge and belief. It challenges the idea of rational belief itself. How can it be rational to believe each ticket will lose individually while simultaneously knowing one must win? Philosophers suggest this paradox arises because our reasoning about probabilities differs when thinking about a group versus thinking about individual cases. In broader terms, the lottery paradox quietly points to the limits of our intuitions about probability and belief. It nudges us to realize that even logical reasoning can produce contradictions when applied to large-scale scenarios. And gently, it reminds us that the world is full of situations where common sense, logic, and intuition can sometimes lead us astray, showing that uncertainty and paradox might be deeply woven into the fabric of rational thought itself. Picture this scenario. You enter a quiet room and see 2 boxes placed neatly on a table. One box is transparent, clearly holding $1,000. The other box is opaque, hiding either $1 million or nothing at all. A highly advanced being, one who has never been wrong, predicted your decision in advance. If the predictor guessed you'd take both boxes, they left the second box empty. If they guessed you'd take only the second box, it contains $1 million. Now you're faced with a troubling decision. Do you take both boxes, guaranteeing at least a little money, or trust the predictor's accuracy and risk it all for the million? This puzzle, known as Newcomb's Paradox, was devised by philosopher Robert Nozick. At its core, it pits two powerful forms of logic against each other. On one hand, rationally, the outcome is already determined. The money is either there or not, no matter your current choice. By this logic, you might as well grab both boxes and maximize your winnings. Yet, another intuitive voice whispers differently. If the predictor is consistently right, your best choice is clearly to trust their foresight and take only the second box, thus maximizing your expected reward. Newcomb's paradox challenges the idea of free will and rational decision-making. It suggests that the very notion of rationality might change when dealing with a future that has seemingly already accounted for your choices. If a choice is predicted perfectly, are you truly free to choose otherwise? The scenario forces us to consider whether we live in a deterministic universe, where future events, even human decisions, might already be set in stone. Philosophers still argue heatedly over the best response. Some fiercely defend taking both boxes as the rational choice, while others passionately insist that the second box alone is always smarter. But the real lesson of Newcomb's paradox isn't about right or wrong, it's about the complexity of choice itself. This paradox gently suggests that perhaps our decisions, and even our free will, are entangled with the future in ways we cannot fully comprehend. Imagine a teacher announces that there will be an unexpected exam next week. She promises students won't be able to predict the exact day beforehand. At first glance, the announcement seems straightforward, but then a student starts to reason carefully, and the promise begins to unravel. The student thinks, if the test hasn't happened by Thursday, Friday is the only remaining day, making the exam predictable, so Friday is impossible. Thursday would similarly be predictable if it didn't happen by Wednesday, eliminating Thursday as well. By this logic, Wednesday, Tuesday, and Monday can all be eliminated. Therefore, no day next week can truly surprise me. Feeling relieved, the student confidently concludes there won't be an exam. Yet, Wednesday morning arrives and unexpectedly, the teacher hands out a surprise exam. The student is stunned. The prediction, so carefully reasoned, turned out completely wrong. This scenario, called the Paradox of the Unexpected Examination, or Surprise Test Paradox, reveals a curious contradiction. It explores the tension between logic and expectation. Each step of the student's reasoning seems sound, yet the conclusion, that no surprise exam could occur, ends up entirely incorrect. What went wrong? The paradox arises from the self-defeating logic hidden inside predictions about predictions. By reasoning that the exam couldn't occur, the student unknowingly created the exact conditions needed for a genuine surprise. It's a circular puzzle. By confidently believing they've outsmarted the teacher's logic, students inadvertently ensure the teacher's success. The paradox of the unexpected examination gently exposes the limitations of our logical reasoning when dealing with self-referential predictions. It reveals that sometimes, trying too hard to predict the future can blind us to simple realities, reminding us that life itself often defies our attempts at absolute certainty. Imagine two identical twins. One stays on Earth while the other boards a spaceship traveling at speeds approaching the speed of light. The space-traveling twin journeys into the depths of the cosmos for what feels like only a few years. Eventually, he turns around and returns home, excited to share stories of his adventure. But upon reunion, something astonishing happens. The traveling twin finds that his sibling has aged dramatically, while he himself has barely aged at all. This scenario, known as the twin paradox, emerges from Einstein's theory of special relativity. According to relativity, time passes slower for someone moving at incredibly high speeds compared to someone stationary. Yet, from each twin's perspective, the other twin is the one in motion. Why, then, doesn't each twin find the other younger upon reunion? The resolution lies hidden in the subtlety of acceleration. The traveling twin experiences changes in speed, accelerating, slowing down, and turning around, breaking symmetry between their experiences. The twin on Earth remains in a relatively consistent inertial frame, while the traveling twin undergoes acceleration and deceleration, fundamentally altering their experience of time. The twin paradox challenges our intuitive notions of time as absolute and universal. It forces us to confront the startling truth that time is flexible, relative, and dependent on motion and gravity. What we experience as seconds and minutes can be entirely different for someone else, traveling through space at extraordinary velocities. As you reflect gently on this paradox, consider that perhaps every moment you've ever experienced is unique to you, your personal journey through time distinct from everyone else's. Time, it turns out, isn't a uniform ticking clock but a deeply personal and uniquely subjective experience, quietly defying our assumptions and inviting us to reconsider what now truly means. Long ago, the ancient Chinese philosopher Zhuangzi awoke from a vivid dream in which he was a butterfly, gracefully floating and completely unaware of being human. The dream was so real, so immersive, that when he woke up, he found himself deeply troubled. He wondered, was he truly a human who dreamt he was a butterfly, or was he actually a butterfly now dreaming he was human? This simple yet profound thought experiment is known as the butterfly dream paradox. It highlights an unsettling truth. Our perceptions of reality might not be as certain as we assume. Zhuangzi's dilemma points out that experiences within dreams can be indistinguishable from those of waking life. If our senses and minds can be so convincingly deceived during sleep, how can we ever be certain about the reality we experience while awake? Philosophers and thinkers have pondered this paradox for centuries. Modern cognitive scientists affirm that our brains indeed construct reality from sensory inputs, often filling in gaps or interpreting events in ways that might not match external reality. Neuroscience confirms that our brain's perception of reality is essentially an elaborate construction, continually shaped by internal and external inputs, potentially blurring lines between dreams and wakefulness. The butterfly dream paradox gently nudges us to question the very foundation of our perceptions and experiences. It quietly reminds us that certainty might be an illusion itself, that reality may simply be whatever our mind chooses to construct moment by moment. As you drift closer to sleep, let this paradox softly lead you into dreams of your own, where reality and imagination flow seamlessly together.